Hi everyone, Assalamualaikum. With me, teacher Siti Razilah Osman from SMK Tinggi Melaka. My subtopic for today is topic 5.1 Fundamental of Wave. Okay, our learning outcomes or objective for today's lesson is first, student should be able to describe wave. Second, student should be able to state the type of wave. Third, students should be able to compare transverse wave and longitudinal wave. Fourth, students should be able to explain the characteristic of wave. That is, amplitude, period, frequency, wavelength, and wave speed. Fifth, students should be able to sketch and interpret wave graph. We have two types of wave graph, that is displacement time graph and displacement distance graph. And the last one, the objective is to determine wavelength, frequency, and wave speed from the calculation. Wave around us. We use to see, to feel, and to listen to the effect of wave in our daily life. We have water wave, sound wave, earthquake, that is seismic wave, light, and color. Okay, what is wave? A wave is the spread of disturbance that carries energy, or a wave is a type of harmonic motion, repeats itself. Okay, this is an example of a wave, that is sound wave produced by a guitar. We produce Wave produced along a guitar string being plucked is an example of a stationary wave. A stationary wave is a wave where the profile of the wave does not propagate with time. So from the textbook, you can scan the QR code that you can observe the profile of the stationary wave. Okay, the yellow one is the stationary wave that we have scanned from this QR code from textbook. Okay class, what is mechanical wave and electromagnetic wave? So mechanical wave requires a medium to transfer energy from one point to another. Mechanical wave made up of vibrating particles of a medium, such as water wave, sound wave, and seismic wave on the surface of the earth. What is electromagnetic wave? Electromagnetic wave does not require a medium to transfer energy, made up of oscillating electric and magnetic fields perpendicular to one another, such as radio wave, light wave, and gamma rays. So we can learn further electromagnetic wave in subtopic 5.7. Okay, wave travel faster through solid and colder objects. Why? Because the molecule of the solid and colder object are closer together compared than liquid and gas. So wave travel faster through solid and colder object. Okay, we have two types of wave. First is transverse wave. So what is transverse wave? Transverse wave is vibration perpendicular to the direction of wave travel. For example, water wave and electromagnetic wave. Okay, student, you can observe the motion of a transverse wave in these animations, which the particle of motion is perpendicular to the direction of propagation. The second type of wave is longitudinal wave. What is longitudinal wave? Longitudinal wave is vibration of particle is parallel to the direction of wave travel, or parallel to the propagation of the wave travel. For example, sound wave. Here, student, you can observe the motion of the longitudinal wave, which the particle motion is parallel to the propagation of the wave motion. Okay, uh, what is one complete cycle? One complete cycle is calculated when the object moves from one point and end at the same point. Cycle, repeated part of motion that start and ends in the same spot doing the same thing. For example, the cycle of the pendulum start from point A to point C, and from point C go back to point A. We call it one complete oscillation or one complete cycle. Okay, what is a ripple tank? Ripple tank is an apparatus to produce water wave. So, student can observe the pattern of the wave. Okay, we can find this image from your textbook. Okay, the water waves are produced by a vibrating bar on the water surface. The tank is level so that the depth of water in the tank is uniform to ensure water wave propagate with uniform speed. If we get this result, we call this as a plane wave. Okay, if the wave is in this shape, the shape is called a circular wave. So, to determine the wave graph, we have to know what is the definition of term related to wave. First term is amplitude. Amplitude use letter A. Okay, definition is maximum displacement of a particle from its equilibrium position. Period T, the time taken by a particle to make one complete oscillation or by a source to produce one complete cycle of wave. So what is frequency? Frequency is number of complete oscillations made by a particle or number of cycles of wave produced by a source in 1 second. Wavelength, wavelength use symbol lambda. Distance between two consecutive points in phase. Wave speed, V, small letter, distance traveled per second by a wave profile. Okay class, this is a picture or part of a wave. So, where is the amplitude? Amplitude is the maximum displacement from the peak to the equilibrium state. Okay, this is amplitude. Okay, what is wavelength? So, one wavelength we calculate from here to here. Actually, from this picture, we can observe two wavelengths. First wavelength, second wavelength. First wavelength, this is second wavelength. Okay, here is peak, this is peak, and this is trough. Okay class, I explain again what is amplitude. Amplitude is the maximum displacement from its equilibrium position. Amplitude relates to the loudness in sound and brightness in light. So what is vibration? Vibration is the movement from one extreme position to, to the other and back to the same position. So wavelength, which is lambda, lambda is the distance between two adjacent points of the same phase on a wave. For example, the distance between two successive crests or two successive troughs. Okay. This is the distance between two successive crests, and this is the distance between two successive troughs. Okay. For sound wave, we have compression part and rarefaction part. from one compression part to another compression part, we measure it as 1 lambda, or from one rarefaction part to another rarefaction part, we call it 1 lambda too. Okay, again, what is frequency? Frequency is the number of oscillation in 1 second. Frequency measured in hertz. What is period? Period is time taken for one complete oscillation. So the unit for period is second. So what is wave speed? The speed of a wave is a measurement of how fast a crest is moving from a fixed point. The relationship between speed, wavelength, and frequency is V equal to F lambda. So from this topic, we can sketch two graphs, that is displacement distance graph and displacement time graph. From displacement distance graph, what we can determine is the amplitude and the wavelength. And from displacement time graph, we can measure the amplitude, the period, and also the frequency of the wave. Okay, this is a wave equation. What is the wave equation? V equal to F lambda, which V is the speed of wave, F is the frequency, and lambda is the wavelength. Okay class, what is the relationship between period and frequency? So, period and frequency are inverse of one another. T is equal to 1 over F, which is T is period, F is frequency. So, T is inversely proportional to the frequency. Okay class, we have finished our lesson today. Let's have some exercise on this topic. Exercise number 1. The figure shows the waveform of a slinky spring which vibrates at a frequency of 8 Hz. This is displacement distance graph. So determine the amplitude. The amplitude is here. So the amplitude is 2 meter, which we get the value from the y-axis. Okay. Determine the wavelength. So wavelength, from this picture we have two wavelength. One wavelength and two wavelength. So 2 lambda is equal to 2 meter. So 1 lambda is equal to 1 meter. Can you understand that? And see, what is the wave speed? So to calculate wave speed, we can use formula V equal to F lambda. So V equal to F lambda. So frequency given is 8 Hz and lambda is 1 meter. So the wave speed is 8 meter per second. For number 2 and number 3, you can try it yourself. And the final answer is here. So let's try. Okay, that's all for today. Thank you.